everyone, this is Nat over here from the NextSec team, and I am so excited to be working on a security project today. This is about threat detection with GuardDuty. Now, have you done anything with GuardDuty before? Are you new to threat detection? Are you familiar with web apps and how to protect web apps? All of these questions will be answered in today's project. So if you are a complete beginner, just know that this is super beginner friendly, and I am just really excited because this is a great project to do as well. A big shout out to everyone that's already in the chat and saying hi. Thank you, Marzena. Thank you, Nikhil. Thank you, Amisha. Thank you, Ariana. Thank you, Andrea. I hope you enjoyed this project. This has been one of the top projects I think we've created so far on security. So if you're also a security fan in general, then I think you're gonna love this one. All right, let's get into it, team. So welcome to this project on threat detection and GuardDuty. This project lets you step into the shoes of both an attacker and a defender to see how real-world cyber attacks can work on web apps. By the time you're done with this project, you'll have some practical experience with spotting and exploiting web vulnerabilities. So these are basically attacks that will happen because a web app wasn't set up properly with all of the security best practices. We're also going to be using GuardDuty, which is a machine learning powered threat detection tool to help detect and analyze these threats that we're going to do on our web app. So this project is really ideal for roles like security analyst, maybe a penetration tester, a cloud security engineer. But I think in general, if you're developing an app, you'd be very curious to know whether or not your app is following security best practices. So whether you're a developer or someone that's focusing on security, it's important to understand web vulnerabilities. It's important to understand how can attackers, exploit your web app, what are those techniques, and then how can you use threat detection to protect yourself as well. And cool, I also just thought that it's really fun to have a bit of a preview about what we're doing in this project. So we're gonna get ready to deploy a vulnerable web application. We're going to be using CloudFormation to instantly deploy a web app that's already been set up within this template. So we don't need to set up this web app from scratch and then get into threat detection. This web app's already been set up pretty much. We just need to deploy it. And yeah, this web app is vulnerable. It's on purpose because after we deploy it, we're going to turn on hacker mode, and then we're going to use some hacking techniques to try steal some credential information. We're going to see how this web app is vulnerable, and then we're going to use that to our advantage, steal some information, and then steal some important data as well. Okay, so after that, we switch back into our original kind of web app hoster mode, the person that deployed that web app, and we're gonna go into GuardDuty to see, as the person that deployed the web app, how did GuardDuty do in trying to detect these threats that happened, when the attacker tried to attack your web app. And this is our secret mission for today. So our secret mission, which is a little add-on that you can do at the end of this project, it's an optional thing that you would do to really boost your skills with threat detection. This secret mission is about implementing malware protection as well to safeguard data that you maybe store in an S3 bucket. Cool. Making the space to say hi to everyone that's joining. Oh my gosh, this is so cool. Thank you, Karthik, for saying hi. Also, a big shout out. We have Noob Gamer saying that it's 2:36 a.m. in India right now. Oh my gosh, it's so cool. We have Leo saying hi, Nat. Hi, Leo. What the heck? That's so cool to see you. Amisha is saying a really sweet comment about being excited for this project. And absolutely, you can still follow along by watching this guide. Drew says hello from Western Nigeria. Wow, we also have another hello here. Thank you so much, everyone. Hello. Cool. So we're going to be using the high touch guide for this project. Let's do this step by step. And we'll start by recapping what we're here to do today. So in this project, we will demonstrate how to use a machine learning powered threat detection tool called GuardDuty. We'll use GuardDuty to protect, or really detect, attacks that happen to an insecure web app we've deployed. We're doing this project to learn, what's your personal reason for learning this? Is it something that you want to have more experience in, threat detection? Are you just interested in security in general? Well, in this case, we're doing this project to learn more about AI services, maybe, in AWS. That's a totally valid reason as well. Great work, team. Let's keep on going. So, of course, to kickstart this project, we're going to need to deploy a web app. So guard detection is a threat detection service. There's really no better way to learn about it than by deploying an app that GuardDuty needs to protect. So in this first step, we're going to set up a web app, and it's going to be very insecure. It's full of security vulnerabilities on purpose. So after we deploy it, we'll attack the web app, like a hacker would, and then we'll check if GuardDuty detected our own attack. Don't worry, we won't need to build the entire web app from scratch. You can do this in another project that we have about 3-tier architecture, but in this project, we're focusing on the security side. So we'll be using a CloudFormation template to automate that deployment process. Okay, cool. Do you have any questions about the plan for today's project? If you do, add it to the chat. We can talk about that for sure. Cool beans. So that's what we're focusing on in this cheeky first step. We're going to be deploying that web app using CloudFormation. Now, there's a lot to talk about with the web app we're deploying. You might be curious, okay? Totally fair if you are. Okay, so what's in this web app? Why is it insecure? What is the web app going to look like? I have so many questions. I don't know what I'm going to see. Totally fair if you're thinking that right now. Just know that the deployment of this template takes a little bit of time, so let's focus on deploying it first, and then during the waiting time, we're going to talk about what it is we've actually deployed and understand it so that we're very efficient in the time that we're spending in this project. Cool. So in this step, we will deploy a web app using a CloudFormation template. Deployment takes about 10 minutes, so we'll spend that waiting time on understanding the resources that make up our web app. And if you want, you can even say we will deploy an insecure web app to make it very clear. All right, all done. And yeah, hi to everyone that's coming through. I know this is super exciting. I'm seeing some new names. So Anitha says hi from the UK. We got Terry, hi from Texas. The whole world's here today, everyone. Barca says hi. It's 10 p.m. in Madrid. Quite an interesting topic to follow before sleep. Wow. Is this project going to be released in 2 days? It's actually out now. So there's a link in our description in our YouTube stream that's happening right now. If you check out the stream in YouTube, you'll see the link to the project. Cool beans. Oh yeah, final shout out to Andrea, based in Italy. That's so cool. The whole world truly is here. Thank you, everyone. Thank you so much. Hi, Paul, and hi, Alejandro. It's all coming through. I'm feeling really, really stoked. Oh my gosh, hi from Saudi Arabia. Hi, Abdullah. Hi, Praneeth. Really, really cool to see Praneeth tuning in from Hyderabad as well. And we have Shubham saying hey. Hi, everyone. Okay, So let us get into the project and let us log into the AWS Management Console as your IAM admin user. So I'm already logged in here, nice and easy. So we can get straight into going into CloudFormation so we can deploy our web app. So I'm gonna find CloudFormation over here. Found it. And we're gonna deploy the web app, nice and easy. All right, well, you can see that I have an existing stack here. That's for a different project, so we don't need to worry about that too much. We'll actually focus on creating a new stack with new resources. Make sure you select with new resources, not with existing resources. Choose this one because we'll be creating new resources today, and we'll be using an existing template. That's right, we're uploading a template file. Okay, so we're gonna be uploading this template file that we have prepared for you. So what you gotta do is right click on that link we have here and then save the link as, and save this setup template that we have here. Now, if you don't have access to this template, you can always try find a similar template that will deploy the same web app, and I will give you tips on doing that later on. I will say the template that we've created is like specifically designed for this project, so my highest recommendation is to use this template, the one that we are providing here. And we'll select the file and then upload it straight away. Great. Now, if you're new to CloudFormation and you're thinking, what is CloudFormation? Think about CloudFormation as an infrastructure as code tool that helps you deploy resources instantly. Usually when you're deploying resources, you might be defining everything piece by piece, clicking things in the console, doing maybe running like lines of like commands in the terminal using CLI. You might be defining these resources one by one, but CloudFormation is where you can use one single template, which is this template we've created here, to in one go just say, okay, I want this, like create it all for me now. And then off it goes to creating all of those resources for you. It's super, super helpful for deploying entire applications like this web app we're deploying without you having to think about all of the different parts, of that web app. So we'll give it a name, this stack, which is called, next or GuardDuty project. Replace this with your name, and select next. Go all the way down here, and notice that there are some stack failure options. So this is basically telling you, oh, what should we do if we have some sort of failure in the middle of deploying your web app? All of these resources, there are lots of resources in here. Sometimes one of those resources might fail, This happens a lot. An example is if you want to create a VPC as a part of this template, but turns out your region has already maxed out the number of VPCs that you can have. I remember it's like a smallish number, it's like 6 or 5 or something like that. You can't have too many VPCs in a region. So if your template says, let's create like new VPCs and your region's already maxed out, then your template might fail. You won't be able to deploy everything. So CloudFormation here is asking, okay, so what should I do? Okay, what should I do if one of those resources fail? You can choose to either roll back everything that has been deployed. You can say, okay, I know one resource has failed, but I just want to remove the entire template, remove all of the resources you've created so that my account is back to where it was before. And that's going to be the option we choose today. It's just a cleaner option to maintain, to clear out all of the resources in your account. So you don't rack up any accidental charges if you leave anything in your account. And then we'll just make sure we're deleting everything, if there is an error. So select delete all newly created resources here. Great work. We're going to check this checkbox that basically tells CloudFormation it's allowed to create some IAM resources, which is very much required, and I'll talk about why when we go through what's inside the template. Okay, great. So we have set up our template now. Woo! And we can talk about our final checklist. So in your review page, you can say, is the heading that says prerequisite prepared template heading, does that say template is ready? Okay, yes it does. It says template is ready. Check that off. Is there a template URL? Let's see. There is a template URL. Great. That means our template is existing somewhere, which is good. Is there a stack description that says the following? Ooh, ours doesn't, but this one is optional. You can choose to do this. You don't have to. But for us, actually, sorry, I just realized the stack description was already a part of the template we've uploaded. So if you can see the stack description, it means that your template has like successfully loaded, and you can see that there's something that you can refer back to in the future. If you're like, oh, why did I deploy this? Oh, right, I deployed this template for this specific project with Nick's work. All right, and then you have a stack name next to a GuardDuty project, and make sure you add your name in there. I'm just going to use a generic name, but I would recommend that you replace this with your actual name to keep it unique. Then there are 5 items in your parameters section. Okay, I know I skipped through the parameters section just now, but it's so that we can talk about it here because it's a bit clearer here. So the parameters section is a section that people can define in a CloudFormation template. So let's say I want to help, is there a name in this chat that I can use? Marzena. So there is someone called Marzena that I want to help create some resources. And I write Marzena a whole list of resources. I'm like, dear Marzena, here's this template. It's going to help you deploy 100 resources. And it's going to create this really cool solution that you can use right away. Thank you very much. Please give it a try. Now Marzena's going to be like, great. You know, I have this awesome template with 100 resources inside. But maybe I want to change a few things about these 100 resources. You know, for example, maybe I want something to be private instead of public. Maybe I want an EC2 instance to use a different kind of instance type or a different kind of AMI. Maybe I want, maybe I have a specific port, or maybe I have a specific rule in this security group that's in this template. There are some things about these templates, these resources that you're deploying that maybe Marzena wants to customize. So she's going to tell me that, hey, by the way, like, is there an easy way I can customize the AMI, the VPC, this security group rule? And I'm like, oh yeah, of course. Like, if you want to customize it, let me write up a parameters section so that there's an easy way for you to enter your custom values. So this is the parameters section. In this template, there is a parameter section that's given to you. We're not going to touch it because these are the default settings that will deploy the web app perfectly. But if you really have your own preferences around like networking, preferences around how you want to deploy a web app, this is something you can use instead. In our case, we're not going to touch it, you know, but if you're someone that has a very, very custom requirement, you know, for your VPCs and your EC2 instances, then you can go for that. All right, but that was the parameters section. And, you know, we don't have any tags or permissions, which are additional settings that we don't need to use to deploy a template. So what's more important is we need to make sure that the stack failure options are activated. So this is the setting that tells us that, you know, if there was an error or a failure, CloudFormation will automatically delete these resources. So let us just check that off. And off we go. We're going to submit our template. I always feel nervous when this happens. I feel a little nervous whenever I send off a stack. Because sometimes there can be an error in the middle of it. Most of the time there isn't. But, you know, I've had my experiences with stacks where you might get errors and errors and errors and you need to fix your template again and again and again. In this case, because this template has already been provided for you, you don't need to write it from scratch. Hopefully you're less likely to run into any errors. But if you do, just know that the Nixer community is always here for you to ask any questions. It's at community.nixer.org, and you can ask anything you like. All right, so off it goes with trying to deploy everything that makes up, this web app we're trying to deploy. There are some events that's going to happen. Look at all this stuff that's already happened in the last 30 seconds. In our case, we can go through a few questions I see coming through in our stream, and then we can also talk about what we're really deploying here. Okay, so thank you, Yusuf, for asking, will this be available after you finish the stream? Absolutely. A recording of this will be in our YouTube channel under the Streams tab. Can I make one using Terraform? So this is Abdullah asking whether we can replace the CloudFormation template with Terraform, and the answer is definitely yes, you can. You can use Terraform. I have not used Terraform myself for this, but knowing the resources that's inside this template, it should be possible to write a Terraform template for this instead. Classic, we have Noob Gamer, number 1, saying, sorry to interrupt. I'm using Instagram and mobile. I'm just seeing a crop screen. So if you'd like to see the full screen, the entire recording, or like I understand that you're seeing kind of like a cropped version of the stream right now. So Noob Gamer, check out the stream over YouTube so that you can see it in full screen with nothing cropped out. Thank you so much. Hello, blessed laws, coming from Ghana. Thank you so much for coming along. And yeah, thank you so much, Praneeth, for saying this is super cool to see on Insta Live. Thank you. Siobhan says, Cloud Practitioner just cleared. Congratulations. What the heck? That's awesome. Congratulations to you. We have Yusuf saying, I need to pay for a subscription to access it. So this project demo is absolutely free to watch and follow. It's on our YouTube channel. If you want to see the project guide, that does require a pro subscription. So you'll be able to see the details of our pro subscription by checking out our pricing page. It should be about, well, as of today, we've just updated the pricing. So I would definitely check out the latest pricing page to see the latest updates. Thank you. Asuma says, my first time being live with Natasha. Hello from South Portland, Maine. Oh my gosh, Asuma, welcome. This is exciting, isn't it? Oh, I feel so happy. Thank you so much for making the time to come along. All right, team, that was a really nice break. That was a really great refresher. CloudFormation is going to take a bit more time to deploy everything that's in our template. So while we wait, let's truly explore exactly what we're deploying and why it's insecure. So this template that we've deployed is going to deploy 27 resources. I know. What? 27 resources. And most of it is already done creating. It's actually just one more, I think, that we still need to deploy over here. So what are these 27 resources? Why do we need it? How does it make up a web app? So the web app we're going to deploy is a copy of a very, very popular web app out there for security training. That web app is called the OWASP Juice Shop. So if you're familiar with the OWASP Juice Shop, I hope I'm saying it properly. If you actually say OWASP Juice Shop, that would be a shocker to me. But in the meantime, I'm going to call it the OWASP Juice Shop. And it is truly one of the top applications or things to use to learn about web app and security training for web apps. So once you're done deploying the web app, it's going to look like this. This is the homepage that we're about to see. Now, you can definitely follow these links to see the official Juice Shop, but truly, the OWASP Juice Shop is designed by a group of people called the Open Worldwide Application Security Project, and they're a nonprofit online community, so shout out to them for creating this web app that we can copy and use in this project. And honestly, a great cause or a great group to be a part of if you're interested in security. This group is dedicated to improving software security. They create these free resources. They create projects like Let's Create the OWASP Juice Shop so other people can learn about security, and anyone can contribute to these projects too. Now, this Juice Shop that we're deploying is built with many security flaws on purpose, so that security engineers like yourself can practice finding and fixing security problems, in a very safe environment. You're not truly hacking into some web app that's out there in the world right now, but a lot of them will have the exact same vulnerabilities as this practice Juice Shop web app that you are deploying. So I know we have 27 resources in that template, but honestly, a lot of it can be grouped into a few buckets, a few key categories, and these are the main ones that we should think about or really care about. Cool beans. So the three main categories that our 27 resources make up in this template. The first part is the web app infrastructure. So this is basically the web app itself, the OWASP Juice Shop. The second part is an S3 bucket that we're deploying for storage. And this is an S3 bucket we're deploying aside from the OWASP Juice Shop. So that Juice Shop can live without this S3 bucket, but in this setup, in this deployment template, we are adding this resource for a very specific reason. I'll go into it soon. And the third part is GuardDuty for security monitoring. Now, you can see those three groups again. So you have your main web app, the OWASP Juice Shop. The infrastructure is made up of, the CloudFront distribution, EC2 instance, and a VPC. Here is that S3 bucket we're deploying on top of that web app, and then GuardDuty that's here to protect them all. So this web app is going to be hosted by a web server, which is the EC2 instance. So our EC2 instance is really responsible for being the engine that runs our web app files. So this is the engine that is storing the web app files that make up the OWASP Juice Shop, and it's also responsible for running it, processing it, so that when people want to visit the web app, that there are files to see, or there's a web app that they can look at in their browser. And if they decide to log in, if they decide to buy something, if they decide to delete something, there is some back server code that needs to run to make that happen. When you decide to click a delete button in your screen, that thing actually goes away and disappears. Why? Because this EC2 instance, this web server, is running that code in the background for you. Next up, of course, is the VPC, and these are all of the networking requirements for your web server. As you might learn if you've done our VPC series before, making a web app public actually requires a few settings. You need to make sure that your VPC is connected to an internet gateway. There's a route table, there are security groups, network ACLs. There are a whole bunch of networking resources that you need to set up to enable that connection, between your end users in the public, in the wild, and with your web app that's inside your AWS environment. So there are a bunch of VPC resources that makes this happen, and that's the reason why when we're done deploying it, you can actually access your own web app, which is pretty cool. Next up is the CloudFront distribution. So this is how your web app can be distributed to the entire world, and how a lot of web apps function today. So you would use a distribution like CloudFront, which is also called a content distribution network. But anyway, we're just going to call it CloudFront. So you're going to use CloudFront to say, okay, I have a web app, I have these files, can you please distribute my app's files around the world so that people around the world that wants to see my web app can access those files very, very quickly, so the website loads very, very quickly for them. So that's like the summary of the web app infrastructure. If I'm going too fast, by the way, or if there's something I'm not clarifying, please let me know in the chat. That's very, very helpful for us too. So that's the infrastructure part. And then we have the secure bucket. So, the secure bucket stores a text file called important information text, and it's meant to simulate some sensitive data here. Your web server, so the EC2 instance, has access to the objects in this bucket. I honestly should be highlighting this because it is just that important. Your web server, the EC2 instance, has access to the objects in this bucket. So this bucket contains important information, and we're also telling you that this web server that runs all the code for the web app has access to this bucket too. This is an important part of the vulnerability or the insecurity of the web app that we're about to exploit later in this project. So this part is quite important. And yeah, that means, look at this line of connection. So you're saying a user over CloudFront gets access to a web app, and the EC2 instance that is running the files for the web app also has access to some very, very, very important and secure confidential information too. So there's almost like a line of access that can get a user from the outside all the way into the bucket. We'll see how an attacker will be able to achieve that soon. And of course, we have GuardDuty that's supposed to be looking out for threats and making sure that if anyone actually tries to do that, a user trying to get access to the secure bucket, if anyone tries to do that, GuardDuty picks up on it and they'll alert you straight away as the person deploying the web app. Okay, so note that GuardDuty is already enabled in this template, and later on, after we hack into the web app, we'll be jumping back into GuardDuty just to see whether it's picked up on the incoming threats. Okay. And thanks to everyone that's wanting to get access to the project guide. I can see that perhaps the link was set up in a funny way, so I have just updated it now. So if you don't mind refreshing your tab on YouTube, you should be able to see a fixed link in the description box as well. Great question from Amisha as we dive into, the meaty parts of this project. So is this important information text? It has sensitive data that GuardDuty will detect? Not quite. We haven't gotten, so Amisha's question is asking, so does GuardDuty just happen to know that important information is some sensitive data? And does GuardDuty just automatically know, oh, like I should be looking out for this one file because it's so important? Not quite, okay, this isn't quite the situation here. GuardDuty is actually here to just protect your entire AWS environment, so it's out there to just detect, like, has anything suspicious happened? For an attacker to get access to your, oh, whoa, that was fun. For an attacker, from the outside, to get access to the secure information, they're gonna have to do some shady stuff, okay? They're gonna need to be doing some shady things in order to really get access to your bucket all the way from your web app. So in the middle of all of these shady things that the attacker's about to do, and we're gonna be doing those shady things together, can GuardDuty pick up on this like shady activity and alert you? So to answer Misha's question, so GuardDuty will be picking up on some suspicious activity, but it's not because we've told GuardDuty, hey, look after this important information file. It's because GuardDuty is set up to just detect like things that are happening in your environment and let you know about anything suspicious that might have just happened there. Cool. Usually, once GuardDuty triggers that something suspicious has happened, it's actually up to you, the cloud security engineer, to look at the logs that GuardDuty has written for you. Say like, hey, I found something suspicious. Like, check out these logs. Check out this suspicious activity. And then it's up to you, the security engineer, to look at those logs, decide whether or not it really is a security threat, and then act on it. Cool. Cool, I hope that helps. All right, so let's get into it. To set up for this project, we deployed a CloudFormation template that launches an insecure web app, which is the OWASP G-Shop. The three main components are the web app infrastructure, an S3 bucket, and GuardDuty, protecting our environment. Great work, everyone. Cool beans. So GuardDuty, what is GuardDuty? Ooh, good question. Let's answer that. GuardDuty is an AI-powered threat detection service, which means it is designed to help us find any security attacks or vulnerabilities that affects our AWS resources or environment. If you want to add more to your definition, you can always scroll back up and have a look at this. Definition of GuardDuty too. You can mention that it uses machine learning to look for unusual activity. For example, in your network traffic, in CloudTrail activity logs, but really just know that it's out there to just look for suspicious behavior, something that's unusual, something that's out of the norm for your account. And that's the reason why machine learning is a part of the service, because you need to have some machine learning to be able to say, okay, I have analyzed the activity for this person's account. Oh, look at this bit of activity that's a bit out of the normal. I can tell that it's out of the normal because I have created a whole model about what's normal for this account. And now I've picked up on something that's outside of that, what is, this definition of normal for this account. So because of that, it detects that something was suspicious and it alerts you so you can investigate. So once it detects something unusual, it's up to us to investigate. In the end, it's still up to us to actually stop the attack. It's still up to us to actually prevent something from happening. GuardDuty is about detecting things. It doesn't exactly do all of the protection or, stop people for us. That's another important thing to know. Great. So don't forget, this project is about threat detection. So we've deployed the web app with a CloudFormation template so we can hack into it straight away. And so that we can spend more time in GuardDuty and analyze whether it's picked up on your attacks by the end of this project. So let's mention that too. The web app deployed is called the OWASP Juice Shop. I realize I've repeated myself, but that's okay. To practice our GuardDuty skills, we will attack the Juice Shop and then revisit, and then actually, not instead of revisit, let's just say we're going to visit, and then visit the GuardDuty console to detect and analyze its findings. Does it pick up on our attacks to our web app? That's really what we're trying to figure out today. So first we're going to attack the Juice Shop. We're going to go into GuardDuty, see whether or not it's detected those attacks, and then we're going to analyze the findings that GuardDuty gave us. Sounds like a plan? I hope so. All right, so let's get back into CloudFormation, and hooray, it says create complete. That is a beautiful thing to see for me. I've seen too many of a red word that says something failed. So to see that it's completed is like, good to know. Thank goodness. All right. And if your stack status does say that, don't fret. There's always a solution to it. You got this. If it says it's still in progress, wait a bit longer. If you see that error message, and clearly I've seen that error message before, have a look at what the error message is about. Expand this arrow, check it, see if you can resolve that error by yourself, or if you need help, you can always ask the Nextweek community. Cool. But for now, we're going to take a screenshot of the console to say, okay, stack creation has completed, and we can definitely access our deployed web app. Cool. Great work, team. Let's upload that now. And enter that. Cool. So that was a big chunky step 1 to go through. I totally get that. Just know that the project gets a bit faster from here. It's a bit more fast-paced from now. So we're gonna go into our web app that we've just deployed, and now we'll enter hacker mode. Okay, we're now in hacker mode. We're now the hacker, and see whether we can hack our way into the web app and exploit a few things. So first, we're gonna open this running web app that we've deployed, and then we're gonna use a hacking technique to bypass logging in to the web app we've deployed. So in this step, we will access the web app we've deployed. Next, we'll use a hacking technique to bypass the web app's login page. Great. So let's go into the CloudFormation console and select Outputs. This should show you a few outputs, and if you're wondering what is the output section, just know that the output section is this section that the template writer, so in this case Nextweek, who wrote the template, would say, okay, once they've deployed the web app, can you write in the output section this URL, so it's very easy for them to find the URL of their web app. Can you also export this value, so it's very easy for them to figure out, A, B, or C, like something that maybe you'd want to know about your web app. Outputs is kind of like this final list that comes out after you successfully deployed your template, and it's like a summary of the key information you should know. In this case, the URL is definitely some key information that we'd want to know. This is the public URL of the application we've just deployed. So let's right-click on it and visit our web app. Yay, here we are. This is the web app that we've just deployed. Welcome to the OWASP Jew Shop. I hope you enjoy your time here. So we're gonna dismiss this pop-up, which was a quick introduction to the Jew Shop, and we're gonna have a look at our next step. Okay. So this is the web app you've deployed with your CloudFormation template, and the web app itself is a shop. Like, it's literally a shop where you as a customer can add things to a cart, check out, and buy some things online. But there's also an admin page in the back that requires a login. So say that you're the Jew Shop owner and you set up a page in the back that says, as a Jew Shop owner, I can log in and edit a few details about my web app. So let's take a screenshot to say that we've entered into our web app. That's a nice milestone to hit. What do you think of the Jew Shop? It's so cute, isn't it? Look at all these random things that you could buy. Egg fruit juice is so cute. I feel like there's a lot of hidden Easter eggs that is quite cute about this shop. So you can definitely spend your time exploring. There's so much to see in here. Okay, now that we've entered the web app, it's time to put on your hacker hat because you've now entered hacker mode. We're gonna pretend that we're the hacker for into this web app, and we've just visited this shop, and we decide, okay, I'm gonna try steal some data from this shop. You are no longer the person that deployed the web app. Right now, we're going to pretend you're a hacker that's trying to hack into this web app. If it helps, you could even try to do this in an incognito tab, something that's away from your usual browser window, to really make you realize that you're now a hacker. You're not the person that deployed this web app. Up to you, totally your choice. So as the hacker, you're going to go into the top right, select the account icon, and log in. Okay, and now the hacker doesn't have a login. They are not an admin of this page, but they want to get inside. So what are you as the hacker going to do? How can you get through this login page? If you have any suggestions, add them to the chat. Would love to know what you do as a hacker to get through a login page like this. So on the login page, our solution is to put in this mysterious string, into the email field. I'm going to copy that, and we're going to paste it inside email. So this is actually something that is like a security attack, or something that you can take advantage of as an attacker. What you're doing here is a technique called SQL injection, and we're going to take a screenshot of it before we talk about what it means. Great. Let's put this in. Awesome. So what you've entered here looks pretty simple, right? Like you've just entered, apostrophe or 1 = 1, semicolon, dash dash. Looks pretty strange, but also, I guess, pretty simple to type out. So how is this an attack? What have I really done here? So it looks simple, but you're really doing an attack called an SQL injection. So SQL injection is a vulnerability that happens when an attacker can put some malicious SQL code into the application's database queries. This can let them bypass authentication, it can help them steal data, or even change the entire database structure. Not a joke that SQL injection has genuinely happened in some huge web apps around the world, causing companies to lose a lot of data or lose a lot of money because of maybe important information getting deleted, or lots of customers having their accounts removed from them. So it's a huge vulnerability that still exists. And what's happening here when you typed in this value is you've actually manipulated the SQL query used for login. What usually happens when you're logging into a web app like this is you type in your email, you type in your password, and what the web app does in the background is it grabs the values of what you've entered, and it passes a formula or a query using SQL, which is a language to talk with your database. And it's basically telling the database, hey, do we have a user with this email and with this password? Yes or no? Give me the answer, yes or no. So the web app is going to grab these details and it's going to go ask the database, do we have it? But what you're doing here is you're kind of manipulating the code that your web app is going to give to your database by saying, hey, do we have someone with this email? And by entering this, your database, the database that's supposed to answer that question, is always going to reply yes. Doesn't matter whether or not this was actually an email in there or not. The moment it says 1 = 1, it's like, yeah, 1 = 1. The answer is yes, like it's true. So this is the part of the code that's truly malicious. It is really injecting into the code that passes through to the database, reply yes, say yes. So your database is gonna go yes, even though the web app was actually asking whether there's an email with this value. But your database will see this part, it's gonna say, yes, this is true. Then your web is gonna be like, oh, it's true? Okay, great. So someone does have this email and this password. Type in whatever password you want. This part doesn't even matter anymore because your database has already replied yes from this part. So you can literally type any gibberish into the password field. And then you can just select login. And I think we might need to take a screenshot of this, so I'm gonna keep a screenshot for now. But you can just log in. Look at that, we just logged into the admin portal. So how we did that was the fact that we have used SQL injection to manipulate what our user database says to our web app. So our web app is always going to get the response yes, and because of that, the web app says, oh, database says yes, come on through, come log in. And just like that, us as the hacker got access into the OWASP Jew shop. Okay, that was pretty quick, wasn't it? Yeah, it's very, very interesting how quickly attacks like this can happen. All right, the first attack we performed on the web app is SQL injection, which means injecting malicious code, malicious SQL code that manipulates a result from our web app. SQL injection is a security risk, and it's a serious one. It's truly happened in the real world. You can definitely search up the news about it, about latest companies that have been attacked because of SQL injection. But in our case, let's answer this first. SQL injection is a security risk because it can let attackers bypass login. It can also let attackers, what else can they do? Delete data, or I can say, or edit data. Great. So what did your SQL injection attack involve? So my SQL injection attack involved, what did it involve? It involved entering the code into the email field of the login page, of the web app's login page. This means the login query will always evaluate to true, i.e. our database is manipulated into telling our web app this login exists. Pretty intense, isn't it? Amisha also says, yay, my first ever SQL injection. Even I just logged onto the Juice website. That's awesome, Amisha. To everyone else that's watching this and also wanting to give that a try, you can always search up the OWASP Jew shop. There should be a public version of the OWASP Jew shop that's available out there, and you can hack into the website yourself, hack into the admin console yourself using the same technique that we just did. Congrats, by the way, Amisha. That's awesome. Okay, so we've just logged in, and there's also a banner, you might have noticed, up here that says you solved a challenge. Interesting. If you're wondering, what was the challenge? What did I just solve? What was happening here is that that challenge is not related to this project, but it exists in the world of OWASP Jew shop anyway. So it's not actually relevant to this project, but I thought you might be interested in knowing more. The OWASP Jew shop is actually designed with more than 100 hacking challenge built inside. So you can go into the OWASP Jew shop, you can play around with different ways to attack it, hack into it, and then each time you do something correct as the hacker, it's going to give you a green banner and it's going to say congrats, you just completed a challenge. So by us logging into the admin page, we pretty much along the way, solved one of those 100+ hacking challenges that the Juice Shop has. You don't need to solve all of these problems to complete this project, but if that interests you, like you want to solve more of these challenges that comes with the web app, you're so welcome. There's even a official challenges section of the Juice Shop website that you can visit to see all of the challenges that you can try solve. Great. For us though, for this project, let's move on to step 3, which is about exploiting the web app. So now that we've bypassed login, good job, we're gonna stay in hacker mode and do the next thing. We're gonna, now that we have access into the admin console, or the admin console for the web app, we're gonna see if we can steal some credentials that belongs to the web app host AWS environment. Uh-oh, do you know what that means? So you've guessed it. You're the web app host, okay? I know we have the hacker mode on, but you're the web app host. You were the one that also deployed this web app. So as the hacker, you're gonna find a way to expose your own AWS environment details. It's pretty dangerous stuff. As a heads up, this credentials that you're exposing are not credentials that gets access to your entire AWS environment. It's only to the S3 bucket you've also deployed. Okay, PSA, someone that also does this to your web app and sees these credentials, they manage to do the same thing and expose your credentials, they're still not gonna get a lot of access into other things. They're only gonna get access to this random S3 bucket that you've deployed in this template. So it's a safe thing to expose, but let's just pretend that as the hacker, this was such important information. There was such important information in that S3 bucket that definitely just getting access to that bucket is well worth the effort. Okay, so in this step, we will use a second hacking technique to expose some credentials that gets us access to the web app host AWS environment. Great work. Okay, so now that we're inside the Juice Shop, we are going to click into account, and then we're going to click into this first option where we enter a profile page. All right, here we are in the profile page. Great work, team. So now that we're in the profile page, we're going to click into the username field, and we're going to enter the following code. So I'm going to copy that code, and I'm going to enter it here in the username field. Okay, a pretty chunky command to be entering here. Whoa, it's huge, isn't it? Yeah, it's a huge command. So we're going to go through the entire command step by step together so we can break it down. If you're curious about this command and you want to give this a go, I've also just pasted the command in the chat so you can check it out as well. Great. So you're going to enter this piece of code in the username field, and then you're going to click Set Username. Whoa, did you see that? What do you see is different? Can you tell? So something has changed here. We have a little thing inside the username, in the username section that says object. Interesting. Okay, so for now, let us figure out what we've entered into the username field. Why do we enter something so long and complicated? And then we're going to break down what this means. A hi to everyone that's saying hi, by the way, over Instagram. Hello, hi, Wajab. And we also have a Traveler Musto saying hey, hello. Hello, Haidar, and thanks for saying hi as well. And Piyush, good to see you. And hi to Reina too. And Cloud Security with Ray. This session has definitely started, by the way. It's good to see you. Hello to Gagans as well. Good to see everyone doing this project together. Okay, so first of all, why do we just enter code into the username field? I thought the username is for names, it's not for running code. So what were we doing here? Okay, so this is actually another technique. First thing we did was SQL injection. Now this part is called command injection, which is something slightly different. So to understand command injection, imagine if you ask someone for their name, but instead of giving you their name, they give you this piece of paper that has a command that like puts you in a trance, and it makes you unlock your phone and give it to them. Isn't that crazy? It's like you just got hallucinated. But that's essentially what's happening in this admin portal here. So as the hacker, the admin portal was like, hey, what's your username? And we just gave them this piece of code that puts them in a trance and makes them unlock something in the back end. So that sneaky trick is called command injection. It's a security vulnerability just like SQL injection. But in this case, instead of passing some code for our database to automatically say something is true, what's happening here is we're passing some code for the web server, for the EC2 instance, to actually run some code instead of storing a username. Your web app truly expected a straightforward username. You know, it might have been expecting something like Amisha. That's my username. But instead, it got a script, and that script was designed to steal keys. So keys to your EC2 instance's IAM credentials are now exposed because you entered a piece of code that the web server received and then ran as well. This type of vulnerability can really let attackers access some sensitive information. It can let them manipulate some services, even take over the entire EC2 instance and and make that EC2 instance run, all of their code and rack up some bills to whoever owns that EC2 instance as well. All right. So the root of this issue, if you're thinking, oh gosh, like I'm creating web apps, how do I make sure I don't have this vulnerability myself? The reason why our juice shop has this issue is because our web app doesn't clean up or check data that it receives. Here's kind of like the story that's happened. Your web app, you've designed the web app, or whoever created the OWASP juice shop, designed the web app to take in a username in the username field. Okay, and it's designed to just take in the username field as it is and run some code to store it. Next, the attacker accesses this profile page. The attacker puts some code into the username field. Next, you click on set username as the attacker. That immediately means the web app goes and retrieves the username and tries to run some code to set this as your username. But as it runs the code to set this as a username, it ends up running the actual code that you've inputted here itself. And this code that you've inputted tells the web server, oh hey, like while you're running this piece of code, why don't you give me your IAM credentials to the AWS account where this EC2 instance belongs, and expose those credentials, make it public to the world. Why don't you do that? And your EC2 instance, as it runs like this code and tries to make it the username, it's like, oh, sure, like let me do that. You've asked me to do this. Let me just run that piece of code. So it goes and it runs the piece of code which successfully exposes the EC2 instance's credentials to your AWS account, and it makes it public to the world. Okay, that's pretty scary stuff, but it truly happens because of one key thing that the person that set up the web app didn't do. It didn't tell the web server, hey, before you run whatever username gets entered, make sure you clean it. Make sure you go over the username and double check that it's not code. Make sure you double check that the username entered is actually just some plain text that does not turn into code. If the web app had set it up to include that check, or include that conversion where it converts everything that enters into plain text and will never execute it as code, then you would have been fine. But in our case, because the entire thing was not cleaned, it wasn't sanitized, that is a more technical term for this practice. Because it wasn't sanitized, that means that the web server just ran the code and has, unfortunately, exposed some important credentials into the world. Cool. So I know I've just explained at a high level what that piece of code does. But if you want to go into more detail, you can also check out this, you can also dive into all of the details of different parts of this code here as well. Overall, just know that the code retrieves some important credentials that belongs to the EC2 instance that is hosting this web app. So it goes and retrieves that, and then it itself gets access to those credentials. And then it saves those stolen IAM credentials in a public JSON file within the web app. This is the most important part of the code, because this part says that as the hacker, you've just made those credentials accessible to anyone that visits the web app. Anyone that visits the web app and knows the path to this file that you've saved those credentials in will be able to see those credentials that got exposed. Cool. I hope that's clear. Let me know if you would like a deeper discussion about what was happening in the code. We're going over it in a more high level so you can focus on the security part of using GuardDuty to detect this threat. But if you have any follow-on questions, let us know in the chat. Let us know in the comments. We'll definitely check it out. Great. So let us answer this question. And a call out of this, I just noticed that this is an outdated version of this question. So it actually is command injection that we're using here, not cross-site scripting. So please make sure you're mentioning command injection. Cross-site scripting isn't quite the right term to be using here. Okay, so next we use command injection, which is a technique that manipulates the web app's web server to run code that has been entered in a form. The JuShop web app is vulnerable to this because it does not sanitize user inputs, i.e. Inputs. I would want to say that there is a keyword here. It doesn't strip out or block like harmful scripts or commands. All right, sorry about that, team. I know I was mulling over a few things quietly just then because I was trying to figure out what was the best way we could answer this together. But truly we could say, next we use command injection, which manipulates the web app's server to run code that has been entered, for example, in a form. In this case, the form was the username field that we entered. The DrewShop web app is vulnerable to this because it does not sanitize user inputs, so it does not block scripts from getting entered and run. We have a great question in the chat here. We have Amisha asking, I'm sorry, but I didn't observe what changed when we click on set username. Great question, Amisha. So let us try this by entering something else. So before Amisha, if we were to enter a username, we could say Amisha as our username, for example, and let's set that. Do you see how Amisha becomes the username here? But what happens when we actually put in our command injection code? You know, all this code, what happens to the username field? Let's set the username again. Now it becomes object. So this is something that has changed in the username field because we've put through some code. For some reason, the username now renders as object, which is quite interesting, and we have an explanation for it. Okay, so like Amisha's asked, check if the profile's username has changed to object like this. And if it says something different, if it looks a bit like this, make sure you've just run the entire script and that there are no errors and no typos in what you've entered. Great work. So if you're wondering, why is that username showing object? Like that's such a strange thing to be showing. Here's a quick explanation. So command injection is a type of security vulnerability, and it's where an attacker can inject some commands into the server. That's what we did. We, as the attacker, put in some code in the username field. Okay, the server failed, to properly identify that this is some malicious code, and it just ran the code. The username is designed to just display some text, but right now it's defaulted to object because it's trying to display an entire JavaScript object. So by seeing this in the username field, that's how you know as the attacker that you have just succeeded. This code that you put into the username field, the goal of it is to create a file called credentials.json that exposes the IAM credentials of the EC2 instance. So if you see object in the username field, that's how you know, the web app says a JavaScript object has been created. Then that means my script would have succeeded. The JavaScript object, this field is now trying to show, but is struggling to show, is actually the file or the credentials file that I've created through this piece of script. So if that was confusing, let me just explain that again. This piece of script is telling your web server, hey, go create a file. Go create a file. It's going to be called credentials.json, and use that to store the IAM credentials of you, the web server, to the AWS environment that you belong to. Once you've created that file, make that file public within the web app. That file should be somewhere. And by seeing object in this profile username field, what you're seeing is a confirmation that a file has been created somewhere. All you have to do now is go and find that file. All this does is confirm to you that congratulations, as the hacker, you've created the credentials file. It doesn't show you the credentials that are inside. All it does is give you confirmation that the file's been created. I know I just said the same thing like 20 times because I understand this is something that can be a little bit tricky to understand. But if that was still a little bit confusing, let us know in the chat. So let's take a screenshot to confirm and show in our documentation that we have succeeded with our command injection. And awesome. I just wanted to take the time to quickly call out some requests to zoom out, screen is too big, and that you can't seem to see the whole thing. And again, for Instagram viewers, just know that Instagram Live automatically crops the side of any live that we run that's in horizontal view. So unfortunately, that means if you'd like to see the whole thing in full screen view, please check it out on YouTube. We're actually streaming live on YouTube right now. You can find us over here on our YouTube channel under the Streams tab. If you find this, as you might guess, that is exactly the same stream as what you're watching right now. And yeah, this one will be in full screen mode. It won't be cropped. Thanks, everyone. And let us keep on going with our project. So we're going to go into, oh, I see we have another question here. So will that file credential.json, is that stored in S3 or EC2? It will be stored in EC2. Great question from Amisha. So don't forget, currently all of your web app files are stored in EC2. And because of that, when you create a new file, that file will also be stored in your EC2 instance as well. What your S3 bucket is storing instead is it is actually storing some important information that's not really related to the web app files. It's kind of a separate file. Imagine like you have some web app files, but you have a separate file that's like, this is our bank account number, and you just stored that in an S3 bucket connected to the web app. That's kind of like the important information that's inside S3 right now. But let's get back into focus and have a look at the stolen credentials that we stored somewhere. You can actually access it right now because, like we've mentioned, we've made the credentials publicly accessible. So let us copy this, put that in our browser, and make sure to replace the placeholder for JuShop URL with the URL that we've been given in CloudFormation. There we go. So just like that, you can see that the credentials that we've exposed in our code is now here in front of us. We can see that there's an access key ID, there's an expiration date, a secret access key. All of this is some super confidential credential information that you wouldn't want to share with anyone. To see that it's now publicly accessible, this is literally a public URL that you can even enter into your browser right now to get access to this object. It's a pretty dangerous thing. But again, like if you're worried right now, just know that these credentials don't actually give anyone much. It just gives them access to that S3 bucket that we've deployed earlier on. Cool. So these credentials will give you access to AWS resources in the developer's account. Whoever possesses them can interact with the AWS services just like the web app can. So whoever now has access to these credentials can now, interact with you as a developer and get access to those resources. In our case, it's just that S3 bucket, but in other people's cases, there's so much sensitive data, so many resources, so many costs that could be associated with that access key, those details. So you really wouldn't want to give that away. If you're curious, these are the different components that make up access to your AWS environment that you can do over the CLI. So we're going to be using a special way to access an AWS environment that's not logging into it over the console. It's more like you're getting access through the CLI, through some commands. And this is kind of like your username and password for getting access through those commands. Cool. So we're going to take a screenshot of these credentials that we've exposed. And again, because these credentials are temporary and they don't give you access to much, just know that putting it in your documentation is not going to be an issue. Okay, and we're going to answer another question. To verify the attack's success, we visited the publicly exposed credentials file, i.e. credentials.json. This page showed us access keys that represents this page showed us access keys that represents the, I would say, that can give anyone access to the resources Okay, I'm going to update the explanation. So to verify the attack success, we visited the publicly exposed credentials file called credentials.json. This page showed us access keys that represents our EC2 instances access to our AWS environment. It gives anyone can use those keys to get the same level of access as our EC2 instance. We can use those keys to get the same level of access. Phew. I have just one letter left. Okay, round 3. To verify the attack success, we visited the publicly exposed credentials file. This page showed us access keys that represents our EC2 instances access to our AWS environment. And we can say like to the developers, AWS environment. We can use those keys to get the same level of access. Oh, great question again from Amisha. I think Amisha is asking some great questions, so there's nothing to apologize for. If I am a root user and I have not generated any access keys and secret keys, will this credentials.json then show my username and password? So great question, Amisha. And to clear this up, the credentials that you're exposing here, over here in this JSON, these are not your own credentials to your own AWS environment. These are the credentials that your EC2 instance is using to get access to your AWS environment and access other resources like your S3 bucket. So rest assured that you don't even need to generate some access keys, or you don't even need to generate some access keys yourself for this to show, because this would have been deployed already as a part of the CloudFormation template. Your EC2 instance would have needed some access to start with in order to get access to your S3 bucket. And that access is in the form of these temporary access keys that your EC2 instance can use to unlock the S3 bucket and get access to the objects inside. This means these keys would have been created at the moment you deployed your CloudFormation template, and it's not related to your own login to your AWS environment. So no, your username and your own password to your AWS console is not going to get exposed at all by doing this. The only credentials that's going to get exposed is not your own credentials, it's your EC2 instances credentials, which is something else. Cool, I hope that clarifies it, and thank you for the great question. Cool, so we're going to just do one or two final things now. Step 4 is we're going to steal some data with these stolen credentials. So now that we have stolen credentials into the AWS environment, we're just going to stay in hacker mode and do one last move, which is to steal the sensitive data stored in the web app. Steal the sensitive data stored in the S3 bucket, sorry. So to clarify, with those credentials that we now have stolen from our EC2 instance, we're going to go into the AWS environment as the hacker and try to use those credentials to get access to the S3 bucket. To do this, we really need to use Cloud Shell as the hacker and run some commands that will use the permissions granted by those credentials. This part is a little bit confusing to understand straight away, so just know you don't need to understand this part right now. We're going to see it in action later. Cool. So don't forget, you're the person that deployed this web app. You're the person that deployed the OWASP JuShop here. So the S3 bucket you're hacking into, the environment you're hacking into, it's all a part of the CloudFormation template that you've deployed. You won't be actually hacking into someone else's AWS environment. This is totally legal and safe. What you're accessing isn't truly confidential information either. So it'll be, you won't be exposing like illegal secrets by doing this project. You'll be all good. Great. So in this step, we will enter the developer's AWS environment using the credentials we've just stolen from the EC2 instance running this web app. Using those credentials, once we've entered into the environment, we will also steal data that's been stored in an S3 bucket. Great. I hope that was all clear, everyone. Because there's so many steps and so many different kinds of credentials involved in this project, totally get it if things are feeling a bit confusing right now. So here's a quick recap to get us all, I guess, like ready for the next step and just making sure that we've all kind of understood what we've done so far as the hacker. So far as the hacker, you've hacked into a web app called the JuShop, the OWASP JuShop. You've used SQL injection to bypass the login to get into the admin page of the JuShop. And then in the username field, you've entered some commands, and that was command injection. Those commands you've entered told the EC2 instance that's hosting this web app, hey, can you go and give me your credentials, your IAM credentials that has given you access to an S3 bucket in the back. Your EC2 instance goes and runs the code that you've entered into the username field, and it retrieves the IAM credentials that the attacker wants. Then you as the attacker, you now have access to those credentials that the EC2 instance has passed to you. So your plan now in this step is to use the credentials that's been given to you to access the objects that are inside the S3 bucket yourself. Cool. So to do this, to become the hacker that's going to get access into the developer's AWS environment, we're going to use the Cloud Shell console. Cool. So I'm going to click on reconnect, but this usually doesn't happen to everyone. Usually you can just open Cloud Shell. There's a button for you to click on opening Cloud Shell, and you can get started straight away. Cool. If you haven't used Cloud Shell, just know that it's a place for you to run some commands. And in this case, we're going to go straight into explaining why we're using Cloud Shell. Okay, great. So in this project, we're going to be using Cloud Shell because it's a place for us to run commands related to AWS. So here in Cloud Shell, what we're going to need to do is we're going to enter in some code that says, hey, I have some stolen credentials. Can you please go and help me use these stolen credentials to access someone else's S3 bucket? And then Cloud Shell is going to be like, okay, like what are those credentials? And then you're going to give it the credentials. You're going to set up something called an IAM profile. You're going to say, oh, here are the credentials. Here you go. Now using those credentials I gave you, let's go and steal the data that's inside the S3 bucket. And then Cloud Shell is going to be this tool that you use as a hacker to retrieve that data and open it and see what's inside. Cool. So the attack continues in Cloud Shell. Because this is a tool we can use to run commands that uses the credentials we've stolen. Cloud Shell will be our medium for doing suspicious things like stealing data from an S3 bucket. Cool. And you can be even clearer as well. The attack continues in Cloud Shell because this is a command line tool we can use to run AWS commands that uses the credentials we've stolen. Cloud Shell is now our medium. Cloud Shell is now our medium for doing suspicious things like stealing data from an S3 bucket. So in the Cloud Shell terminal, we're going to run this command that exports an environment variable. So we're going to highlight this. We're going to copy it. Okay, we're going to paste it here, and then we're going to tell it to remember an environment variable called jushop URL. So we're going to say, hey, later in my code, whenever I say jushop URL, I mean this. So you're kind of telling your Cloud Shell environment, can you remember this value for me? The value is jushop URL, and it means this. Okay, so you're just asking your terminal to remember a piece of information so that later on you can easily refer to it without having to type out the entire URL again. Pretty handy. And that is called an environment variable, if you're new to that. Yeah, if you're curious, environment variables are like temporary storage spaces, so you can store information like website addresses or file names, so you can easily access it later. And in this case, we're storing an environment variable called jushop URL so that we can easily store this URL here into a single variable. Great. So next, we're going to set something called the jushop S3 bucket. So here's another variable that we're going to store. We're going to say, hey, now you have to remember a value called jushop S3 bucket. And this jushop S3 bucket is going to have this value. The value is going to be the name of the S3 bucket that you've deployed. So this is the name of the S3 bucket that was a part of the CloudFormation template you deployed at the start of this project. And it's a very, very important one to remember and to store, because this is also the S3 bucket that contains all of the secret information, that's inside. Okay, so now as a hacker, we've kind of stored two values here. The URL, okay, of our web app, and then also the JuShop S3 bucket, which is the name of the bucket that contains all of that important information. Thanks, Amisha, for the great question. Keep it up, Amisha, by the way. These are some good questions. How will the hacker get access to the name of the S3 bucket that we created? This is an awesome question. So by already knowing the name of the S3 bucket, we have just kind of done a little shortcut here. So usually as the hacker, you would run a bunch of AWS commands using the credentials that you've stolen to kind of test, okay, what can these credentials get access to? Because you as a hacker technically don't know. So you as a hacker would usually run a bunch of commands like, do you have access to VPCs? Do you have access to EC2? Do you have access to S3? Oh, you have access to S3. Okay, what do you have access to within S3? And then you would run a bunch of other credentials to make sure like, oh, okay, so you have access to this bucket in S3. And then that's how you will end up getting the name of the S3 bucket. So in our case, we've kind of just deleted those steps after reviewing that would expand this project a bit too far. That would make this project a bit too long. So we're using this almost shortcut instead, where we would assume that the hacker already knows the name of the S3 bucket that we created. Oftentimes, if you're not careful with the name of your S3 bucket, sometimes a hacker would literally spend hours just to guess like bucket names and see which one sticks. You know, is there any chance OWASP JuShop assets is a bucket name? Is there any chance important information OWASP is a bucket name? It can like test this for hours and hours, thousands and thousands of it, before it finally like makes a break and actually gets access to one of those buckets. Great, team. Thank you so much for the questions, by the way, Amisha. That was awesome. Okay, so we've stored two values now, JuShop URL and our S3 bucket. So what's next for us? What's next for us is to bring down the credentials that we've stolen. So like Amisha's mentioned, technically, we would do this first as the hacker, usually. It's more that for the purpose of this project and for learning, we've just decided to make it a bit faster for us by saving some environment variables, pretend we already know what's happening, we already know the name of the bucket, and then later on in these commands are now easier to run because we've saved the variables already. So in this command, we can just say $JuShop URL because we've already saved the environment variable for JuShop URL, so we can use it straight away. So I'm going to copy this command, run it in the terminal, and look at that. It ran straight away and it ran successfully. You can see that this is a success message that things have been saved because we ran a command that contains a variable we've just stored earlier. What does that command do, by the way? Oh, good question. So that command uses a tool called wget. And that is a tool where you can download files from the internet. In this case, we use that tool to download that credentials.json file from our web app and into our Cloud Shell environment. So we actually said wget, so go and download this file that's been exposed into our Cloud Shell environment. Isn't that crazy? So what that means is now inside your Cloud Shell environment, there's a file, as the hacker in your own Cloud Shell environment, you now have a file that contains, this victim, this developer's EC2 instances credentials. You're getting so close now to doing the final hack of getting into the S3 bucket, because now you have a copy of some credentials that gives you access to the S3 bucket, and it's just sitting inside your Cloud Shell environment now. Oh, great question from Ariana. Those credentials that are stolen are part of the normal flow between an EC2 and a bucket, or is this just for the example? Ooh, great question from Ariana. So this is the reason why now it's very, very common for credentials to be given in other ways, like maybe a bucket policy, maybe an IAM role that the EC2 instance has. And you're correct, Ariana. Like, this here is an example of how you can give an EC2 instance access to an S3 bucket. But actually, even if you were to use more secure ways, what you've hacked into here is a very specific service called the EC2 instance metadata service. Okay, it's getting a bit technical, so I'm going to restrain myself from going a bit too far. The full details of that service is actually inside this project guide. It's inside an extra section. But if you were to search EC2 instance metadata service, you're going to learn that what you've actually gotten access to in the back, Ariana, when you stole those credentials, is you got access to a service that contains all the metadata for your EC2 instance, including their access to things. So in our case, when we deployed our CloudFormation template, part of that template was an IAM policy that actually gives the EC2 instance access to the S3 bucket. So in our CloudFormation template, there was a policy in there. It's one of the 27 resources. And that policy says, EC2 instance, you are granted access to the S3 bucket. So what happened there is when we as the attacker ran the command that accessed the metadata service, the metadata service contains that policy. And it contains the access keys that you can use to unlock that policy, basically, to get the same level of access. So what I'm trying to say here, long story short, is that because the instance metadata service is something that is common across every single EC2 instance out there, it's going to be very, very common for EC2 instances and for buckets to be connected in this way, for there to be an IAM policy and the EC2 instance getting access to S3 using that policy. I think what could be an alternative solution to this is to actually have a bucket policy instead. So it was actually the bucket that grants the EC2 instance access. I haven't tried that method myself, but by theory, that should work, where instead of giving the EC2 instance the policy, you're actually giving the S3 bucket a policy that opens up access to EC2. I'm kind of thinking about this as I say it. I think that method should work instead. Like, that could be a more secure way to connect your EC2 instance and your S3 bucket. Okay, I hope that's interesting and helpful, Ariana. If you're wanting to know more, I think the first thing you can go to is visit the EC2 instance metadata service and see how it stores credentials for an EC2 instance. That might help you know a little bit more about stealing credentials and then getting access to like a bucket. Cool. I hope that was interesting. And we'll keep on going. We'll keep on going. Okay, so we've just ran that command that steals the credentials and stores it into the local Cloud Shell environment. So we're gonna run the next command now. This next command is pretty insane. Okay, we're now using cat to say, display the local file. Okay, you can actually run ls as well in Cloud Shell if you want, to read what's inside your local Cloud Shell environment. And here it says, oh yeah, there's a file called credentials.json in your local Cloud Shell environment. So we're going to say, okay, then we're going to use cat to read that file. Read that file, open it basically inside the terminal, and then use JQ, which is another command or another tool you can use to format that nicely. So we can actually break up this command to see the effects. So let's say I just ran cat credentials.json. I just ran this part, which is about reading the file inside. Okay, it doesn't look very, very nice yet. It looks a bit messy, I would say, the output. So what I'm going to do instead is add JQ to that command. And look at that. Now, access key ID and the values of these headings are color-coded, so it's easier for you to see. What is a heading? What is a value? What is a heading? What is a value? And that's why we put this in the command as well. Okay, it's a way for you to just view JSON in a cleaner way. Okay, so let's do a little recap of what we did as the hacker with those commands. So in Cloud Shell, we use wget to download the exposed credentials file into our Cloud Shell environment. Next, we ran a command using cat and JQ to read the downloaded file and format it nicely so the JSON is easy to understand. Cool. So in Cloud Shell, we use wget to download the exposed credentials file into our Cloud Shell environment. Next, we ran a command using cat and JQ to read the downloaded file and format it nicely. So the credentials, which are written in JSON, are easy to understand. All right, all done. And thank you so much to Christian for saying nice Linux command. That's really sweet, thank you. Cool, are we ready now to configure a CLI profile? Why have we done all this work to steal some credentials? Because we are an attacker that doesn't naturally have access to that AWS environment, and we want to use those credentials to get into an S3 bucket that belongs to the developer's AWS environment. So what we're going to do now is we're going to, in Cloud Shell, pretend that we are the hacker, still the hacker, and now say, hey, Cloud Shell, can I set up this profile that contains all of these stolen credentials? So you're going to run this command that sets up a profile called stolen using those credentials. Let's have a look. Let's paste that here, and off it goes. So just like this, we've run a command that says, okay, you know that credential file that we stored? Go read that file and go all the way up to access key ID in the file here, and then go and extract whatever is the value of access key ID, and that is going to become the access key ID of this profile I'm setting up. Again, do the same thing for secret access key. Go and open the file I've downloaded, go and find the value for secret access key, and save that in my profile as the value of my profile secret access key. Same thing with the region, same thing with the token as well. Okay, so now that that's done, you now have a profile set up. A profile, if you're new to that concept, is like a way for you to save settings that you can use to authenticate and access AWS services. Each profile is made up of authentication information, like what you've just saved in your profile, the access key ID, the secret access key, the session token, the region that you're working in. So you can have a lot of different profiles stored on your computer. It's kind of like switching between IAM users. In the console, you can switch between IAM users that says, oh, okay, like now I'm inside a user that has access to like 2 services. Next, I'm an IAM admin user that has access to all of the services. You would kind of use profiles in the same way, but within the same IAM user, so you can switch between different permission settings. In this case, as the hacker, we're saying, oh, let's create a new profile to save some permission settings that gives us access to someone else's environment. We're going to go into someone else's environment, and here are the details of how we're going to get access. So of course, you're going to need a new profile to do that, okay? Because by default, the hacker's own AWS account, like their own Cloud Shell environment, is not going to automatically have access to someone else's S3 bucket. But by saving a profile and putting in all of these stolen credentials inside, you can easily switch to that profile and say, oh, using the credentials in the profile, let us go hack into someone else's S3 bucket. Cool. So yeah, if you're wondering, profiles already exist by default. So usually in Cloud Shell, by default, there's a profile that's set up with the exact same permissions as the user logged into your management console. But for us, we're going to pretend that we're the hacker that didn't have access to the AWS environment, so you need to use that profile with all of the stolen credentials to actually access the S3 bucket. Cool. So shall we go and explain that now? So we then set up a profile called stolen to store and save all of the stolen credentials. We had to create a new profile because the hacker doesn't inherently have access to the victim's S3 bucket. I would say the hacker doesn't inherently have access to the victim's AWS environment. They'll need to use the profile to run commands. We'll need to use the profile I wanted to say we'll need to use the profile to almost like switch permission settings. We then set up a new profile. That stores all of the stolen credentials. We then set up a new profile using all of the stolen credentials. We had to create a new profile because the hacker doesn't inherently have access to the victim's AWS environment. We'll need to use the profile. We'll need to use the profile to switch. I would say to switch permission settings. Yeah, I think we'll leave it there. Was that confusing? Was that clear to you? I would say the recap of this step about creating this profile is 1, the hacker doesn't inherently have access to our victim's AWS environment. 2, they decided to download the credentials that they've exposed, on the web app. They've downloaded these credentials. 3, they set up an AWS IAM profile, which is kind of like a a permission setting or like a set of permissions that you can store into your account. You can kind of like wear a profile, like you would wear a nice, suit that unlocks, different access to different places. In this case, we stored a profile that has access to our victim's AWS environment. And we'll need to wear that profile like a suit so that the hacker can actually go into the victim's AWS environment and hack into that S3 bucket. Otherwise, they wouldn't, without that suit, without that profile, they won't be able to run commands that gives them access to the S3 bucket. I'm just gonna wait 1 minute for anyone to ask any questions about that, because I know that's more of an advanced thing that we're doing right now. So yeah, if you have any questions, if you want me to explain that again, please do ask. And then yeah, we'll just wait the minute. Awesome, everyone. Cool. We're almost done, team. We just have 1 or 2 more commands to run as the attacker, as the hacker, and then we're done as the hacker. So here, we're gonna see that there is this command that copies a file called secret information from the S3 bucket. So let us copy this and run that in the command line. And here we are. What we've done is we've just used the profile called stolen, that new profile we've created, and we said using the credentials provided by this profile, we're going to go into our victim's S3 bucket, and then we're going to steal this file called secret information. So that file gets downloaded into our local Cloud Shell environment. You can even run ls again if you'd like to confirm that. You can see that a file called secret information is now in your local Cloud Shell environment. So what else are we going to do? Now that we have this file inside, our local Cloud Shell environment, some cool things that we can do is to read it, isn't it? So let's use cat to read this file. There we go. So we ran the command that says cat, oh, apologies, I just realized I was blocking the command line. So we just use cat to expose this file that was inside our victim's S3 bucket, and we're reading it. Dang it, if you can see this text, you're accessing our private information. That's right, so this was the bit of text that was inside our victim's secret information file, and it just tells you as the attacker that you have succeeded. What you've done is you've successfully hacked into your victim's AWS environment, you've accessed their S3 bucket, and you've even made a copy of some files that belongs in that S3 bucket. You open that file and you can tell that you've accessed secret information that was supposed to be safely stored inside their environment. Just like that, congratulations, you've gotten access to the company's secret information. So we should take a screenshot and save that in our documentation. Shout out to Ria in the chat saying, I'm late but so excited about this project. Thank you, Ria. I hope you enjoyed this project too. Nice work. So Amisha says that they can also see the file. That's awesome, Amisha. Cool. So what did you do using the stolen profile? Using the stolen profile, we copied. What do we do? Using the stolen profile, we copied, what do you think? We copied an object inside our victim's S3 bucket. The attack was complete when we successfully open the file and verified that we've just unlocked secret information. There's been a data breach, or there's been a data leak. Okay, so what you've done as the hacker. Let us do this recap before we move on, because that was the last thing you did as the hacker. We're going to go back into the AWS environment host mode soon, the web app host environment soon, and we're going to say goodbye to hacker mode. But before we say goodbye and before we finish this step, let us just recap what we've done. Okay, so as the hacker, you visited the JewShop web app, you used SQL injection to bypass logging into the web app's admin portal, and then use command injection to make the web server create a new file, and that new file contains the server's credentials to your AWS environment. You visited that file, which turns out was publicly accessible. This means anyone can visit the file's URL, anyone can see the exposed credentials too. Pretty dangerous. So as the attacker, you ran some more commands to retrieve some exposed credentials from the web app and save the copy of that inside Cloud Shell. Then, with those exposed credentials that you saved in Cloud Shell, you set up a new profile that says, we're gonna wear these credentials like a suit. And then wearing that suit, we're gonna walk inside our victim's AWS environment and then get access into their S3 bucket. So we did exactly that. We accessed our victim's S3 bucket, and we opened and read the contents of a file inside that bucket. The victim's private information was leaked the moment we read those file contents. But yeah, all the way from web app into leaking the victim's S3 buckets and the information inside. So a lot of stuff happened in these 8 steps. Okay, so that's the attack on the web app host, all complete. We're gonna say goodbye to hacker mode now, and then we're gonna step back into the role of the web app host. So as the engineer who deployed this web app, we're gonna go and check out GuardDuty and say, hey GuardDuty, did you detect that something really suspicious happened in the environment? Let's see if it did. So yeah, in this step, we will visit our GuardDuty console to verify whether it's detected our attacker's suspicious activity. Let's have a look. Let's head into GuardDuty now. We should open up the GuardDuty console. And let's see. Aha, there has been a finding. Let's click into that finding. If you don't, by the way, it can take up to 15 minutes for the findings to show. So give it a bit more time and refresh if that's you. Or if you see the finding, like us, we see this finding. Note that a finding is basically a notification that something suspicious happened. A finding tells you what was a suspicious thing that happened, who did it, how did they do it. This helps you understand the attack and fix the problem too. After performing the attack, GuardDuty reported a finding within 15 minutes. And again, if you haven't detected the finding yet, just know that GuardDuty can take literally up to 15 minutes. So give yourself that time to wait, refresh. Sometimes it can take up to 20 minutes. We've seen it happen before when we were testing this project. So it might be a bit of a patience game. But if you're still waiting, you can always read to the end of the project guide, see if there's a secret mission that you can do while you're still waiting. There's definitely stuff that you can do in those 20 minutes as well. I'm sure it's going to pass by fast. Findings are notifications from GuardDuty that something suspicious has happened, and they give you additional details about the who, what, when of the attack. So let's click into the findings option if you like and spot the finding, or you can click directly into that findings number. And yeah, shout out to Amisha who says that they can see it now. Awesome! That's so cool. I'm really happy to hear. Alrighty, so you have the finding that's in front of you. And note that severity, like here it says high, severity is a measure of how serious the attack is. So in our case, it's a high severity attack because it is extremely suspicious that the credentials were used by another account, by the attacker. But sometimes it can be low severity if it's just like, oh, something is slightly out of the norm, but I don't think it's that unusual. Or the hack that potentially happened or the attack that potentially happened isn't that big of a deal. You know, it wasn't too important, not too much. Things could have been leaked from that. Okay, so you have to click into the title to expand it and see more details. And you get to see all the details around what really happened in your AWS account, in your AWS environment. So in our case, we can see that what's really happened is that credentials created exclusively for an EC2 instance have been used. Don't we know what happened in the background? That was us. We got into the web app, stole those credentials that were created for an EC2 instance, and then we used them. You know, we use them as the attacker, which is why it's been detected that they're being used from a remote AWS account. And fun fact, even though we ran those commands in Cloud Shell, commands from Cloud Shell actually register as a different AWS account, which is why GuardDuty would have found it so suspicious. Commands that we run here aren't thought of as commands that are run inside your account. They're actually thought of as commands run inside a different account. And that's why it mentions a remote AWS account. And it chucks in your Cloud Shell's account ID. So you can scroll down and you can see that there's so many details in this finding. This one event triggered this much information. Look at how much data AWS is really collecting on every single thing that happens, you know. This is behavior that happened from another AWS account, but because it's linked to your EC2 instance, it connected you with it straight away. So that's pretty cool. Okay, you can also break down the finding type, which is, as you can see over here, the finding type usually is something that engineers would look at a glance to understand, okay, that's what happened. So in our case, okay, someone has had unauthorized access to some IAM credentials, and the credentials initially belonged to an EC2 instance, and the credentials were used within AWS. So that's how you can instantly, at a glance, look at the type and understand what's happened without needing to read the paragraph version. Pretty cool. So yeah, isn't it so interesting and wonderful? GuardDuty would have used some advanced machine learning algorithms to just always monitor your account's activity. And that's how it would have monitored that there's been some strange things that have happened in your account that is out of the norm for your EC2 instance. So this is called anomaly detection. And really the important thing here is there needs to be enough data for GuardDuty to know what's normal. You know, what is normal for an EC2 instance? What is normal for your account? And was that activity considered normal? And I would say because the account, the EC2 instance's credentials were being used by a different account ID, that really set off a lot of alarm bells. It would have been like, that's not normal. It's not normal. Someone else, another account ID, is using your EC2 instance's credentials. Only one thing should be able to use those credentials, and it's the EC2 instance itself, not another account ID. So that's why it triggered it this time. Cool. So you can use a screenshot to store some of that juicy details that GuardDuty's given you. And answer this question. What was GuardDuty's finding called? GuardDuty's finding was called, and you can copy this over, which means credentials belonging to an EC2 instance in my environment were being used in another account. Anomaly detection was used because I want to say this is unusual behavior. I'm also noticing I have 8 characters left. Okay, I'll say GuardDuty's findings I'm gonna shorten my sentences. GuardDuty's finding was called instance credential exfiltration, you know, the long name that the finding gave you. And it means credentials belonging to my EC2 instance were being used in another account. Anomaly detection was used because this was unusual behavior. Okay, so the more time you spend inside this finding page, the more information you're going to realize that AWS collects on activity and behavior. In this case, you can even see that there are details around the resource ID. So this was the resource that was affected by the breach of credentials. So those credentials were used on your bucket. You see how your bucket is actually referenced here? There's even more details about that bucket. It was an S3 bucket. This is the access key ID that was used. This was the IAM credentials related to what, these were the IAM credentials used to get into that bucket. And this was the EC2 instance that originally had those credentials, and this is the EC2 instance that basically had their credentials leaked. All of the tags related to the CloudFormation template, the auto-scaling group, these are all resources that were used by the CloudFormation template. Even more details about the S3 bucket. My goodness. It said, oh, this was a specific action. It tried to retrieve an object. It can even tell, it affected your S3 bucket by trying to retrieve an object, not by trying to delete the bucket, not by trying to rename the bucket. I don't think that's possible. But actually, it was just trying to get an object. It can even tell. It can even tell the IP address of who did that, the location of that person, which I think adopts the location of your Cloud Shell account, and other information. Look at all of this information that's inside this single finding. So interesting. All right, so GuardDuty's detailed finding reported that an S3 bucket was affected, objects, the action that was done using the stolen credentials was getObject. The IP address plus location of the actor was also available. The EC2 instance, whose credentials were leaked, all right, so GuardDuty's detailed finding reported the S3 bucket that was affected, the action that was done using the stolen credentials, which was getObject, and the EC2 instance, whose credentials were leaked, that the credentials belong to, basically. The IP address and the location of the actor were also available. So just like that, you can select Done and submit your response. So you absolute legend. Awesome job taking up this project on threat detection. So as both the hacker and defender in today's project, you've really leveled up your skills in security vulnerabilities. You've really leveled up your skills in understanding how to protect web apps against these potential attacks. Things like SQL injection, command injection definitely happen in the real world. So look out when you're developing your own web app. Know that you can use GuardDuty to help detect these threats. But even better, know how you can design a web app that protects yourself and prevents these threats too. Cool. So we can get on with our secret mission, which is a very quick fire, I would say 5 to 10 minute activity that you can do to really level up your GuardDuty skills again with something called malware protection. So in this secret mission, let's get ready to use malware protection so to enable like a different way for us to protect our S3 bucket. Previously, we've talked about how GuardDuty is kind of like just looking out for your environment. It just looks out for anything suspicious that happens and it reports it the moment it finds out. In this secret mission, we're actually enabling an additional setting called malware protection. And this is an additional setting where you can now tell GuardDuty, I want you to be like the security guard for this bucket specifically. Like, I want you to be the shield for a specific bucket I'm gonna give you. And then we're gonna see how GuardDuty actually protects that specific bucket from threats like malware. Shall we give it a go? Let's jump in and see how that and let's see how that works. Cool. Okay, so in this secret mission, we will enable malware protection in GuardDuty. This will help us protect a specific bucket from malware, which levels up our threat detection skills. Nice. Cool. And shout out to Amisha. Secret missions, let's go. All right. So in the GuardDuty console, we are going to select the option for enabling malware detection, which is on the left-hand side. Okay, and we're going to scroll down here, and you're going to see that there's an option to enable it. Okay, so let's enable malware protection for S3, and let's make sure it protects a specific bucket. We're going to say, this is the bucket you're going to protect. And what's that bucket? That bucket is going to be the bucket that we've deployed in our CloudFormation template. So let's select it and get ready to enable it straight away. In the meantime, let me scroll through this just to make sure that there's one thing I want to mention, and you can read this as a reference as well. Please note that when you're doing this project before June 11th, 2025, malware protection is free for your account. After June 11, 2025, so well after this live is recorded, if you're watching this around June, July, August 2025 and onwards, know that it is still free for your account if you've been using your AWS account for under 12 months. If you've been using your AWS account for more than 12 months now, what that means is you will be charged for using malware protection because it's only free for users that are under 12 months. If you'd like, you can always try to create a new AWS account as another way to work around that. But yeah, for us, we're going to go into the S3 bucket details panel, and we're going to select Browse S3. We've selected our bucket. And you can leave these two settings blank, like just select the default. And these are additional settings that will help if you want to do some automations. So let's say, oh, the moment you scan an object that does have malware, automatically do this. Oh, and the moment you scan an object that is safe, automatically do that. But actually, I misspoke when I say we keep the default options. You actually want to be selecting do not tag objects. We don't want it to do that. We're not going to set up this automation for this secret mission because it comes with extra costs. So let us select do not tag objects and keep on going. Service access is all about GuardDuty's access to S3 so that it can protect those resources. So the default option is very, very good for that one. And we'll select enable. Great. Cool. For our project extension, we enabled malware protection for S3. Malware is a file that contains threats, e.g., for example, if opening the file will cause a data breach, or a deletion of resources in your environment. We actually also have a definition of malware further up this secret mission. It's near the top over here. And it's about how it can damage computers, malware can disrupt operations. Really, it's just designed to harm. And something that you'll need to know is that GuardDuty helps you protect your AWS resources by scanning the resources, going like, okay, someone just uploaded a S3 object, let me scan it, shoom shoom. Does it contain malware or not? Cool. Okay, so now that malware protection is enabled, just select your bucket and click into the S3 bucket name. This is our shortcut for getting into the bucket itself. Okay, so we're in the bucket itself, and really cool to see that secret information text file is sitting here as well. This is what we stole as the attacker a few steps ago, but that's not what we're doing today. In this secret mission, what we're going to do now is we're going to download some fake malware. So this is malware that is doesn't actually cause any damage. It's just supposed to trigger any antivirus software like GuardDuty by making GuardDuty go, oh, I think that's malware, I think that's malware. It's been designed to do that, but it doesn't actually contain any harm. It's not going to damage your computer. So we're going to save this file, and we're going to try upload it into our S3 bucket. What do you think is going to happen? Because if GuardDuty is doing its job, it should pick up on the fact that we're uploading some malware into the bucket. So let's see what happens. If you're interested in knowing more about this fake malware file, it's called an ACAR test file. And ACAR test files are harmless. They're programmed to just make antivirus software think it's malware. And in our case, we're uploading it just to test whether GuardDuty can detect it. ACAR is actually an acronym that stands for the team that developed this file. It's a bit like OWASP. I think security is full of acronyms, if I'm not wrong. Just a lot of different organizations, a lot of tools, and they all come with their acronyms as well. Cool. And now that we have uploaded it, let's mention that. To test malware protection, we uploaded an ACAR test file into a protected bucket. The uploaded file won't actually cause damage. Won't actually cause damage because the test file is only designed to alert antivirus software. Great. Sneaky though, isn't it? So let's go into GuardDuty now and just check for some findings. We're going to go into GuardDuty. We're going to click on View Findings. And ta-da! Looks like GuardDuty did find something. It's found that there's been a malware scan on your S3 object, ACAR test file. It detected a security risk, but it is smart enough to also tell you that it's not actually a virus. So GuardDuty did two things here. It said, one, hey, malware detected. And two, by the way, I've had a look at what kind of malware it is. Oh, it turns out it's a test file. So just letting you know, I found some malware, but it's probably not actually dangerous. That's pretty smart. So great work, GuardDuty, for finding that. And you can even click on this small little info button to read kind of a summary, a highlight of the finding itself. So GuardDuty even went to summarize the finding to give you all the information in a quick glance. So let's take a screenshot of GuardDuty's finding and wrap up the secret mission too. Great. And let's mention this. Once we uploaded the file, the malware, GuardDuty instantly triggered a finding called, what was it called? It was called malicious file in S3. This verified that GuardDuty could successfully detect malware. It also mentioned that the that the threat type is a card test file, which means it's not a virus. Pretty cool, eh? So GuardDuty instantly triggered the finding that there was a malicious file in S3, but we also went into GuardDuty to see the file that it detected that was malware, and GuardDuty even told us, oh, by the way, it's not a real threat. It's just the ACAR test file that was uploaded. Pretty helpful. So before we go, let us make sure that we've cleaned up all of the resources we created today. This is just such a good move to avoid any unnecessary costs. We're going to delete 3 key things: our CloudFormation stack, the CloudFormation template itself, and then credentials.json, as well as the secret information that has been stored in our Cloud Shell environment. So are you ready? There's 3 resources to delete: CloudFormation stack, the template that we use to deploy everything, and also the 2 files that are inside our Cloud Shell environment. Here we go. Let's start by deleting the CloudFormation stack. Let's head into CloudFormation again. Select the stack. Okay, we've got the stack here. We're going to delete it. Press delete. All done. Off it goes, deleting everything that's inside. The good thing about CloudFormation, again, just like infrastructure as code, is that we don't need to delete all 27 resources one by one. Thank you. We only need to delete the stack itself, which automatically deletes everything inside. Cool. Ready for what's next? I hope you are. So what's next is for us to delete a bucket that contains our CloudFormation template. So a bucket starting with CF templates is going to show up in our S3 console, and this is because CloudFormation automatically created this bucket to store the template that you asked it to deploy. That's something to definitely delete because you don't need that template anymore. Find it. The one that I deployed today would have been this one, which mentions today's date. So I'm going to click on it, select empty, and permanently delete it. Okay. Now that everything inside has been permanently deleted, you can delete the bucket itself. And again, this bucket is not the same bucket as the juice shop bucket. This is the CloudFormation template bucket. So you definitely don't need this too, and that's why you need to manually delete it yourself. This is the one thing that your CloudFormation stack doesn't delete automatically. You have to do it yourself. Okay, and there were some things that we downloaded into our local Cloud Shell environment. So we're gonna need to delete those items too. Don't forget to go up to your Cloud Shell environment, connect to the environment if you are logged out like me, which is okay, just wait for it to run. And when it's ready, you're going to run the commands to remove those files. Run ls to notice that you actually have 2 files inside. One is called credentials.json, one is the secret information, and we can delete that. So we're gonna go and we're gonna select rm to remove, and then enter the name of the file you want to remove. So in our case, remove secret information .text, the text file. Done. Next up, remove the credentials JSON file. Done. Great work, everyone. So just run ls again, and it should be all clear now. If you have heaps of other files inside your environment, that just means those files have already been there since before the project. So they don't belong to this project. They might still be in your Cloud Shell environment, and it's up to you. Do you want to delete it? Do you want to keep it? If you want to delete everything, you can always use this handy code that we've provided here to do that. You can just run this in your Cloud Shell environment, and it should go and clear everything up inside. All right, everyone. Finally, in your local machine's downloads folder, let's go and delete our ACAR test file. We don't quite need that anymore. We also don't need the template that we've downloaded, actually. I noticed it's not here, but we can also drag that into our delete folder. Awesome, everyone. Let us wrap up by writing the recap for today's project. The services we used were GuardDuty, CloudFormation, S3, Cloud Shell, and Cloud Shell. Key concepts we learned include SQL and command injection. We also learned about using Linux commands like wget, cat, and jq. And malware protection. Awesome. Next up, how long did this project take you? Let's answer that. This project took us approximately 2 hours, 2.5 hours, including demo time. The most challenging part definitely would have been getting access to the victim's AWS environment using a profile. That would have been pretty challenging to understand. And it was most rewarding to reveal the victim's protected file as the attacker. And great question from Amisha, by the way. This is back when we were deleting resources. Do we delete that as well? Thank you for asking. GuardDuty should be, the settings should be disabled through that CloudFormation template that we delete. But actually, you can always double check that after the project. It gets disabled for myself, but if that setting ever changes in the future, it's always a good idea to just double check your GuardDuty console, after everything's deleted in your CloudFormation template. Great mention. All right, one more part. We did this project today to learn about threat detection and GuardDuty. Plus techniques like SQL command injection. This project certainly met our expectations and was a good challenge. Right from your heart, let us know what you really think. It's great feedback for us too. All right, and that's a wrap. So well done on completing this project on threat detection with AI. You are now a certified juice shop hacker, the ethical kind, of course, and great work learning all of these new skills as a part of this project. So it seems like it says I still have tasks to complete over here, which is a bit strange because I feel like, I do have something I need to complete. Let me answer this question. Oh my gosh, I just realized there was something that I missed here. So let us mention quickly how we ran the command injection. To run command injection, we entered JavaScript code. We entered JavaScript code that told our web server to expose, we enter JavaScript code in the username field of the web apps admin console. This script will tell our web server to expose the, what does it tell the web server? It tells the web server to expose the server's IAM credentials and save them in a publicly accessible JSON file. Awesome. Sorry for missing that, team. If there was anything else I missed, that would be terrible, but thankfully nothing else was missed. And we should be able to generate our documentation now. That looks awesome, everyone. So you should be able to share this on LinkedIn. And here's a post that we've written already for you that you can share right away. All you have to do here is actually tag us at Nixirc like this. Ooh. And then download your documentation. Oh, I just realized the download documentation button isn't visible to you, but it's right here. And then off you go into saving that in your post too. There we go. So thank you so much, everyone, for being a part of this project. That was so much fun. And you can always tag Nixirc, share your learnings, customize that post, make it yours as you select post. Awesome. And a great shout out to everyone in the chat. Thank you so much, Amisha. You've asked some amazing questions as well. So a big shout out to you. We look forward to seeing the Medium post and the blog. And Marzena, thank you. Karthik, sounds interesting. I hope you enjoy the project and you get to try it. Okay, that wraps up today's project. We'll see you in another one very, very soon. And as you do this project, don't forget to post about it. Share what you've learned and really be loud and proud about this new and very, very hard project you've done. All right, see you in the next one. Bye. Oh, and if you have any questions, ask the Nixirc community at community.nixirc.org. All right, everyone. Bye for real this time. Bye.